survivor into here is 3 plus 1 is 4, and 3 plus 1 is 4. That's another tie. Let's pick the top one. Into here, I have 3 plus 0 is 3. 1 plus 2 is 3. Pick the top one. And down here, 3 plus 1 is 4, and 3 plus 1 is 4 again, another tie. So again, this is still winning, which is good. And the last trellis section, where am I ending up? I'm ending up here, right? So I only need to consider edges entering there. So how many errors along this edge?
1.
1. How many errors along this edge?
1.
Correction, that's not right.
Oh, it's the bottom one. Sorry, that's 1. Yeah.
This is also 1.
1. Yeah.
Okay, so I have 1 plus 1 is 2, 4 plus 1 is 5. So therefore, this is the survivor with 2 errors. Now let's trace that back. Okay. Here, 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 here. So now, what I'm really interested in, I'm almost done, but not 100% done. What I'm really interested in is the input message. I care somewhat about the path, but only so insofar as I can get back to the input message. This is where we start looking at the input side. So this corresponds to an input 0. This corresponds to an input 0. This corresponds to an input, this edge. So that corresponds to an input 0. How about this? This edge
1.
here. This corresponds to an input 1. How about this one?
1 again.
1. And this one?
0.
0. So if I read that off, it's 0, 1, 1, 0, 0, 0. There's the message, and there's the 0 pad. So I can forget about this, and here's my message. So I correctly decoded that with 2 errors. Any questions? So if you had 3 flip-flops, how many states would you have? 8. So basically you'd have trellis sections with 8 states, 8 possible states, and you'd be keeping 8 survivors until the end. But you can already see this is a very powerful code. So I mean, a Hamming code, it's a very simple code. It can only correct 1 error. This is also a very simple code, but it can correct 2 errors. It turns out that this can't correct 2 errors in any possible position. If the 2 errors are sufficiently close together, it can't correct them anymore. But if they're sufficiently far apart, then it's fine. And that's why I picked the errors to be at the beginning and at the end of the code group.
Can I correct 3 given the same assumption?
Yes, if the 3 errors are sufficiently far apart, then yes. That's part of the beauty of convolutional code words. The input message is a stream, so that can be arbitrarily long. So in fact, a convolutional code can decode an arbitrary number of code words. They just have to be sufficiently far apart in the output stream.
That's the advantage here. Given it's so complicated to code, provided the public error is almost very small, then you can correct pretty much all your errors.
Exactly. So I mean, and even this is only conceptually difficult. So you could write a program to implement the Viterbi algorithm pretty easily. So it's a very powerful code. Any other questions? Okay, that is the end of the course.